Welcome to the video grade 11s. We are doing a revision which it's going to be focused on question 1 of your November exam. So I have prepared for you notes where we're going to go through all the things that you need to know in order for you to tackle your question 1 with the utmost confidence in your exams. This is the first page of my notes where I explain to you that you will be required to solve for x and find solutions from quadratic equations and quadratic inequalities, and in those questions you might also be required to make use of the quadratic formula. And first of all, I need to remind you that the quadratic equation, in its standard formula, it reads as y is equals to ax squared plus bx plus c, where the ax squared is the one which tells us that it is quadratic. It's quadratic because there is an x squared, and the bx plus c, it helps us in order for us to sketch the graph, with c being the intercept with the y-axis, and bx telling us just how much it is open or is it closed. So going straight into our notes, we have type 1 quadratic, which is the difference of two squares. This is when we have an x squared minus a number which is a perfect square. So when we have a variable square, x squared, subtracting a square number, c, then we are going to be having a difference of two squares. A difference of two squared is solved in the following way. When we have, for example, a question or an example question which asks us to solve for x, when we have x squared minus 4, we quickly realize that x squared minus 4, it is a variable squared minus a square number, and that number which is being squared is 2. So from that we can be able to use the techniques for difference of two squares. And the technique is this: when you have a difference of two square numbers, a variable square and a number squared, you can go straight away and open two brackets with different signs in them, with a plus sign, with a minus sign. And in the first one you will have, in this case, x plus 2, and on the other one you have what? X minus 2. 2 is the number which is squared in order to get 4. So in order for you to go from x squared minus 4 to two brackets, you needed to what? To find that 2, it is the number which is squared to get 4. Then that number which is being squared, which is 2, it is the one which is going to be what? Inside the brackets. Or in easier terms, all you need to do is take the square root of 4. The square root of 4, or the square root of any number which is on the right hand side of the minus sign. The square root of that number, it is the one that you're going to insert inside the two brackets. And from there forth, you will be able to say x plus 2 is equals to 0, x minus 2 is equals to 0, to get your two values as x minus 2, x is equals to 2. You might ask yourself, why then don't we take 4 to the other side? The problem with that is that when we use a square root, when it's in that case, we might forget that the answer to when we have used a square root is plus or minus. So x is equals to plus minus 2 was going to be our answer. but we often forget that and lose marks and say x is equals to 2. That is the reason why you need to factorize into x plus 2, x minus 2. Here's a second example that I've created for you. And in this one, it needs you to be able to be attentive or to concentrate on what you're doing, because you're given 4x squared is equals to what? 9. You might go straight ahead and say, I want to use square root. But like I said, when you use square root, you might forget one of the signs which are outside the square root, which is plus or minus. So you rather take 9 to the other side. When 9 has gotten to the other side, you can see that, okay, this is a difference of what? 2 squares. And the difference of 2 squared, it is 3 which is being squared. Square root of 9 is 3. So you know that 3 is going to be in the brackets. Then on this side, when you square root 4x squared, you get 2x. So you know that 2x is going to be in what? Inside the brackets. This bracket. This bracket. So in this bracket, it is the square root of what? 4x squared, which is going to be 2x. The square root of 9, which is going to be 3. Then you use what? Different signs, plus and minus. Then you use square root of 9, which is 3. On those, then you solve respectively to get your two answers. You might do it in a different approach, which is to divide by 4 both sides, so that you have x squared alone, which is equals to 9 over 4. Then when you take 9 over 4 to the other side, you have that clarity that it is a difference of 2 squares when you have 9 over 4, because 9 over 4 under a square root is what? Is 3 over 2. And that 3 over 2 appears in our brackets. Then the square root of x squared is x. Then it appears in our brackets. Then we have different signs. From there, we can solve it into the respective answers. And that is the notes that I have on difference of 2 squares. Then the type 2 quadratic, it is the next one on the agenda. The next type of quadratic problems that you might have to solve from this point, it is quadratic equations which require you to factorize. For example, if you're given x squared plus 4x plus 4, you need to realize that it is not a difference of 2 squares. A difference of 2 squares is when a variable square minus what? A square number. There is no minus in this case. So you need to check, can you factorize? The answer, yes. Why can we factorize? How is it possible that we can factorize this? X squared is just x times x, and 4 is just 2 times 2. We quickly realize that x times 2 will be 2x, and x times 2 will be 2x. And when we add 2x and 2x, it will give us what? 4x. So by factorizing 4 to be 2 times 2, we have already found out that you can actually add 2 and 2 to give us the middle term, which is 4x, which is the most important thing when you're factorizing. You are trying to find what values for 4, what values or what factors of 4 can I add to give us the middle term, which is 4x. Because we are going to open a bracket. X squared can be, when we put a square root on x squared, it's x times x. X times x is x squared. And when we multiply 2 and x, it will give us 2x. when we multiply x and 2, it will give us 2x. 2x plus 2x, that's 4x. 2 times 2, that's 4. That means we have successfully factorized the equation. From this point, then what I failed to show you here is that x plus 2 times x plus 2, these two brackets, it is brackets squared, right? But when we take a square root on that, we get that it just takes us back to a single x plus 2. I hope you can see that. And taking 2 to the other side, we are able to solve this as x is equals to -2. Let's tackle a different problem of the same caliber. In this case, instead of having a positive 4x, because we have x squared minus 4x plus 4 is equals to 0. Instead of having a positive 4x, we have a negative 4x. And we have a positive number as our c. But we know that a negative times a negative is a positive. And x times -2 is going to be minus 2x. Then x times -2 times x is going to be what? Minus 2x. So all we needed to realize here is that the number or the term -4x, it is a summation of -2x and -2x, which means that we need to factorize positive 4 such that it is a product of two -2's. When you multiply two -2's, you get 4. So that's all we needed to realize. So using the way that we did in the question above, so here we have what? We have positive, but instead of using positive 2's here, we were going to use -2's. Then they were going to give us what? -2x, -2x. -2x plus -2x, -4x, which is what we have in the middle. So this is just what you need to keep in mind when you factorize. Then further into factorization, we have a scenario where we have numbers like -5 in the middle, the term -5x. We can see that we cannot have even numbers like -2 and -2, +2 and +2. So we need to be smart but by how we're going to approach this. So in this case, we go to the last term, which is -6. What are the factors of -6, which are going to give us -5x? The only way that -6 can give you what? -5x, it is that you have a -6 which is going to add to a +1. And conveniently for us, -6 times +1 is -6. Thus the factors that we have here, it's -6 and 1. Because -6 times x is -6x, and +x times +1 is x. So we were going to have a thing like this: negative 6x plus x, which is what? Negative 5x. So negative 5x. So we just keep all these things in mind when we are factorizing. Then another example, it's an example where our a is not 1 anymore. We've been having a scenario where x squared has an a which is equals to 1. But now what happens when a is what? Is greater than 1. Now a here is 2. A here is 2. So it's per choice. You can divide everything else by 2 so that you can have a scenario where you, instead of having 2x squared, you have 1x squared. You can do that. Nobody's against that. You will get full marks as long as you are able to factorize correctly. But then what I want you to notice here is the middle term. The middle term that we have now, it's positive 3x. Now what I can see with my mind already is that 1 is 1 times 1. So I can only get what? 2x, because 1 plus 1, 1 plus 1, 1 plus 1, 1 plus 1 is 2, and 1 times 1 is 1. So now, how did they get to 3x? If you recall to mind, when we open brackets, we have x and x, right? Then we have numbers and whatever on this side. I want you to see that x times x will give you x squared, but it will not give you what? 2x squared. In order for you to have 2x squared, that means one of the x squared must carry what? A 2. In this case, one of the x squared must carry a 2, and since the number that we have at the end is positive 1, positive 1 is just 1 times 1. So on both sides we'll have positive 1 and positive 1. And kindly enough, or rather conveniently enough, when you multiply 2x and 1, you get 2x. And when you multiply 1 with x, you get x. And 2x plus x is what? 3x. Which means that we have that middle term. So the factorization of this is just 2x plus 1 and x plus 1. So all you need to do here was to notice or to evaluate what you were given to see if is it possible to get the middle term. The first step is to put x inside the bracket. Is it x squared or is it 2x squared? It is not x squared, but it is 2x squared. So that means one of the brackets must have what? 2. If it was 4x squared, that means I must have what? Both brackets with 2x, because 2x times 2x will give me what? 4x squared. But in this case, we only have 2x squared. So only one must have what? A 2. Only one x must have a 2 nearby. And we can factorize it now to what? 2x plus 1 and x plus 1. And when we try to find the x value respectively, we get negative 1 over 2 and negative 1. So I want you to pause the video and do the following x and y questions that I've given there. I would like for you to attempt these so that you can see whether you understand or not, so that you can evaluate where you are. I'm going to put the link in the bio where you're going to get solutions to these. It's going to be free, don't worry. And sorry that I said link in the bio, but I mean in the description. I'm used to TikTok. In the description, I'm going to put the links to these. So yeah, let's continue. I hope you've taken a screenshot. Pause the video, take a screenshot, do these, then yeah. Then we got solutions. Take screenshots so that you can be able to view these when take screenshots of these. Let us come now to the quadratic formula. The quadratic formula given by x is equals to minus b plus minus square root of b squared. This is a common mistake, which is why I didn't correct it. This is a common mistake for learners. Inside there, it is not a plus 4ac, but instead it is minus 4ac. It's minus 4ac. So you must be able to quote it correctly. So we use the quadratic formula when we have no factors. Consider an example below, the one that I've given you there. This one, where we have x squared, 1x squared minus 1x plus 3. This clearly does not have any factors. You can pause the video and try to be able to solve it, but you'll find that it has no factors. Then that means that we must be able to now what? Use the quadratic formula. The quadratic formula now makes use of b, a, and c. We know that a is the coefficient of the x squared, b is the coefficient of the x, and c is the term or the number which is by itself. So we need to, the first step, we need to be able to code these or identify them correctly as they are given. Punch them into the formula, put them into the formula, substitute them into the formula, then we use our calculators to get the answer. Same here, when you're given 2x squared plus 6x minus 5, realize quickly that it cannot be solved into factors. Then from there, use a quadratic formula. Even if the good thing about the quadratic formula is that even if it has factors, you can still use the quadratic formula in order for you to do what? To get these two answers correctly. So all you need to do, substitute a, b, and c into the formula, then give the answers. If you are given an instruction that you must factorize, you must round them off to the nearest 2 digits, then that you must do exactly that. You must follow the instructions as per question paper. Now there is completing the square. Now for when we have quadratic equations where we cannot find factors, we can just complete the square in order for us to get the answers for x. I hope you have done this in class, and if you haven't, let's go over them quickly. The first step is to take c to the other side. C to the other side, then you'll be left with this: x squared minus x is equals to 3. Then you need to add b squared over 4 on both sides of the equation. What you do on the left, you do on the right. And our b in this equation is -1, -1 there. Then it's going to be -1 squared over 4, added both sides. Then this is what we have. By adding b squared over 4 both sides, what we have created is a perfect square on the right hand side. And that square, it is x minus b over 2, all into brackets squared. This is going to be the perfect square. If you open 2 brackets right now and put x minus a half, multiply the 2 brackets, you'll find that it will give you this term up here, because it is a perfect square now. It can be written with using only one bracket, and that bracket is going to be b over 2 here on the number side. Then on this side is going to be x brackets squared. When we have done that, all we need to do is to take square roots both sides. From there forth, we need to remember, whenever we take a square root, outside here it's plus minus. So that's why when I took this half to the other side, I said what? Half plus minus what? 13 over 2. That's where this plus minus is coming from. Then same thing that can be done with this one. But what you need to be careful of on this side is that whenever we complete a square, we need to have x alone. So the moment you take 5 to the other side, you divide by 2. So you do your first step, take 5 to the other side by adding 5 both sides and 5 both sides. Then next thing, it is to reduce x squared so that you can have only x squared without the 2. Reduce 2x squared into x squared. By dividing by 2, you can do so that you can have x squared plus 3x is equals to 5 over 2. And from there forth, you do the steps that we did before, which is add b squared over what? Over 4, both sides. Then from there forth, you can just use one bracket. And in that bracket, you will have x plus what? Plus b over 2, all squared, as we have over there. I hope you don't get confused in transitioning from adding b squared over 4 both sides, which is over here. You must add what? B squared over 2 both sides. Then the next step is to open a bracket where you have x and b over 2. On the top one, we have b over 4, b squared over 4. Then on this one, we only have what? B over 2. Then we square root both sides and solve for x by taking 3 over 2 to the other side. Then there it is solved. That is completing a square. Now let's come to solving quadratic inequalities. Well, an inequality is self-explanatory, where it is saying that two things are not equal. So these are questions which use greater than, less than, to relate the left hand side and the right hand side. We use the same techniques as when we have an equal sign, but there are a key few differences which you must keep in mind when you're doing such questions which have quadratic inequalities. And the key difference number one is that if you multiply or divide by a negative, the sign must change from greater than to less than, and from less than to greater than. What am I saying? I'm saying if you have x is greater than 2, if you multiply by a negative, that means that it must change to, let's just say we multiply by negative 2. That means you will have negative 2x is less than what? Negative 4. Whenever you multiply or divide, you need to change the sign from greater than to less than, and conversely from less than to greater than. So let's look at some examples. If you have x plus 1 is greater than 0, and then you are asked to solve for x, it's an easy one. You just subtract negative 1 both sides. Key thing to remember, you are subtracting. You are not dividing, you are not multiplying, so the sign remains the same. Then you have x is greater than what? Negative 1. Let's look at another example. X squared plus 2x is greater than 0. This is probably most common of a question which you might get here in grade 11. This is a more realistic question. What it's saying is that the graph x squared plus 2x, where is it that it is what? Greater than 0. We need the values of x where the graph is greater than 0. So when we solve this, we factorize, which is our step number 1. Whenever you have a quadratic, I hope you have by now seen that step number 1, for most of the time, it is factorizing. We need to factorize. So instead of taking things to the other side or dividing, most of the time we need to factorize. We do not divide by a variable x. Instead, we factorize out the variable x. As you can see here, we have a bracket x plus 2, then we factorize out x. Why do we do this? It is because we can now take it as if this was an equal sign and say, okay, where is x equals to 0? X is equals to 0 when x is equals to 0, or when x plus 2 is equals to 0. So when you look at that question, if x is 0, if you have 0 outside here, anything multiplied by 0 is 0. So that's place number 1 where the graph is 0. Place number 2 where the graph is going to be 0 is when x plus 2 is equals to 0. That will only be so if x is equals to negative 2. If you take 2 to the other side, then you get what? A negative 2. Now, having gotten the places where x is 0, we have gotten the place where x is 0. These are the x-intercepts of this graph. So we can sketch a graph now, a quadratic. First of all, the graph is what? It is quadratic, and it has a positive a is greater than 0. So it has a positive a, and it's what? It's a smiley. It's a smile. The shape of the graph is a smile. So we can come back this side and draw, or sketch rather, and sketch the graph so that we can see where is it greater than 0. It's greater than 0 here at the numbers which come before -2, or rather which come after -2, because when we go to the left hand side of the negative numbers, we are descending, and when we go to the right of the 0, we are ascending. So all you need to do is come this side and draw an arrow pointing to where the numbers are going to be greater than 0, which is there. To the right, to the left, they are greater than 0. So it's what? X is less than -2. Why is it less than? Because the arrow is pointing to the left. And on this side we see, okay, at 0 it's equals to 0. Then everywhere after 0 it's greater than 0. Then to the right, then you copy this arrow, then you have x greater than 0. That's how you're gonna tackle that question. Let's look at another one. Let's solve more quadratic inequalities. What if we have x squared minus 2x is greater than 3? So we make our notes before anything. It is that we have x squared here. We have x squared where our a is +1. A is +1. So we know that the shape is a smile. That means it's concave up. Therefore, when we solve and we sketch, we know that our graph must be looking up. We already know that it's going to be like this. All we need now is this point where the graph is equals to 0. We do that by factorizing. We take 3 to the other side, factorize into 2 brackets. Then we found that x is equals to -1, x is equals to 3. We sketch that. X is equals to -1 is this point. Then x is equals to 3 is this point. Where is it then greater than 0? It's greater than 0 to the left. So you copy to the left arrow. Then where is it greater than 0? To the right. You copy to the right arrow. Let's look at another question. Here we have a negative x squared plus 5x plus 6 is less than 0. So now this is where we need to remember that whenever we divide or multiply by -1, we get that the sign is going to change. So if we divide by -1 that whole function or that whole polynomial, we're going to get that we have a positive x squared minus 5x minus 6, but the sign changed here. The sign changes to greater than 0. From there forth, we can just find where is it equals to 0. Then we must factorize, get that at x is equals to -1 is equals to 0. Then at x is equals to 6 is going to be equals to 0. Then we use the same interpretations of that to the left it's greater, then to the right it's greater. Then we have those answers over there. More quadratic inequalities. Now we are asked for where is it less than 0, because we have x squared minus 4x plus 3 is less than 0, and we are asked to solve for x. So the first step, it is obviously to factorize. We have found factors. Factors will give us what we call critical values. These are the values where y is equals to 0. These places, it is a critical value. These are x-intercept right there. So we have 1 and 3. 1 and 3. Where is it less than 0? Less than 0. So we are no longer looking at above the line, but we are looking below the line. Below the line, it is from 1 to 3. So we have a closed region, which is what? 1 is less than x and it's less than 3. So whenever we have a closed region like this, we are gonna have an answer in this form. So let's do another one. Solve for x. For the given equation, let's look where is it less than 0. So first step, factorize to find critical values. Critical value number 1 is 1. Number 2 is x equals to 5. X is equals to 1. X is equals to 5. We sketch them. The question says, where is it what? Less than 0. Less than 0 is this region. This whole region. So we put it 1 is less than x is less than 5. The shaded region is where the graph is less than 0. Let's do another one. We have a quadratic inequalities, but we have a greater or equals to sign. So what do we do then? So you need to realize that in previous questions that 1 is excluded. 1 is not part of the answer, but it's saying the number of x is it is greater than 1. The number of x is less than 5. So we are saying it is not 1, it is not 5. Here we are saying it is not 1, it is not 5. It's in between. It is not 1, it is not 5. It's in between. So now, when we have a greater or equals to sign, what happens is that we are saying it is this number and everything in between. Let's look at it practically. So we do the same thing. We factorize as our first step. Then we find that only x is equals to 2 is our critical value. That means that the graph only touches the horizontal line once at x is equals to 2 there. X is equals to 2. And realize that means that it cannot go below, because if it goes below, it will touch 2 times. 1, 2. If it goes below, it will touch 2 times. If it goes above, it does not touch. But if it touches once, that means it's like that. It's like as we see here. So the graph is greater than 0 at all points besides x is equals to 1. So the answer is x is greater or equals to 2. When we look at this sketch, we can see that this sketch, the graph only touches the line once, and that is the only point where it is equals to 0. And at every other point, the graph is what? Above the line, meaning it is greater than 0. Let's look at another question. So this question is asking us, where is that number less than or equals to 0? Where is this polynomial less than or equals to 0? And if we do what we normally do, we divide by 2 so that we can have only 1x squared. Then we have minus 2 minus 1. 2 and 2 give us 1. 2 goes into 4 2 times. Then 2 goes into 2 once. Then we have 1x squared minus 2x minus 1 is less than 0. Since we cannot factorize that, let's try to factorize x minus 1 x minus 1. Do you see how minus 1 and minus 1 will give us positive 1 instead of a negative 1? So we immediately see that we cannot factorize. So we just use the quadratic formula. So if you get the chance, or if it comes out in the exam and you are required to use a quadratic formula with quadratic inequalities, do so. Do not be afraid, so that you can get your two values, which is this value and that value. Punch it into the calculator. It will give you the decimals so that you can know which one is greater than which. But I know that this one is greater than this one, so that's why I have it on the left hand side and this one on the right hand side. The question was, where is it less than 0? It's less than 0 in this closed region, and me and you, we know that whenever it's a closed region, the final answer should be like x must be in between 2 plus root 8 over 2, like that, over 2 minus root 8. We know that we must have something of that kind. So yeah, we are also asked to solve for x, given that x squared plus 7x minus 18 is less than or equals to 0. We do the same steps. First step, factorize, find critical value, x is equals to 2, x is equals to negative 2, place them on that number line, sketch the graph. X squared is concave up, it's a smiley, it's a smile. Where is it? Then we have this. But then they said greater or equals to, so we must not forget that we must put greater or equals to there. Greater or equals to there. Well, I hope this was informative. These are the notes that I had for you, so that I can sum them up really quickly and remind you of the things that you must keep in mind, so that you can be able to ace your question 1 come November exam. It's been great having you. I hope to see you in the next video, so that we can tackle more questions in previous question papers. See you in the next video.